Hi everyone, we're going to start Module 12 today, and Module 12 is all about logic and doing what are called proofs, math proofs. So we're going to start today with something called conjectures and learn what a counterexample is. Now, a lot of times, if we're trying to figure something out in math, one way we can do that is by recognizing a pattern and predicting what's going to happen next. Now the name for that's something called inductive reasoning. Inductive. We're going to learn two different types of reasoning, but for today we'll focus on inductive. Now, when you do that, when you take a look at something, you notice a pattern, and you say to yourself, okay, I think this is what's going to happen next. I think this is the pattern. I think this is always going to happen. That's called making a conjecture. Now, at first, a conjecture is just a guess. What we like to call it is an educated guess. It means it's not just a guess. It's not just like, maybe it's 2. It's an educated guess. It's saying, I've thought about this, and I have a pretty good guess about what this is going to be. But we don't know if it's true yet. The second step is to prove it, and that's what we're going to work on throughout Module 12. So here's how you want to make a conjecture. The first thing you do is list examples. If you're looking for a pattern, you have to have something to find a pattern in. So list some examples of whatever you're talking about and see if you can find a pattern there. And that's step 2. Once you have all your examples, look for a pattern. Then you're going to make your educated guess, or what we call a conjecture. And I just want you to remember as we do this first example, right now it's just a guess. Your conjecture may not be right. We're just noticing a pattern and making a guess. So let's make a conjecture now about the sum of 2 odd numbers. Now sum means add. So what we're going to say is, let's say we're going to make a conjecture about what happens when you add 2 odd numbers. So step 1 was start making examples. So let's do that. 1 plus 1. That's the sum of 2 odd numbers. 1 is an odd number, so I did 1 plus 1, and I get 2. Now that's just one example. Remember, you can't notice a pattern from one example, so let's do more. Maybe I'll do 1 plus 3. Those are odd numbers. 1 plus 3 is 4. Maybe I'll do 3 plus 3. 3 plus 3 is 6. Maybe I'll try some bigger numbers. Maybe I'll do like 21 plus 37. So now I'm making it I'm not going kind of in order. I'm making it a little bit more random. But I am adding up odd numbers. 21 plus 37 would be 58. Maybe we'll try an even bigger number. Let's try like 63 plus 101. Those are both odd numbers. You add them up, you get 164. Well, let's keep going. Let's try some negative numbers. Let's try like negative 11 plus negative 3. That would be negative 14. And then I say, all right, well, I got a pretty good list here. So let's look for a pattern and see if we can make a conjecture. So as I look at all the answers, these right here, these are my sums. These numbers that I just circled in red, those are the sum of 2 odd numbers. And as I'm looking, I think to myself, you know what? There's no odd numbers in there. Those are all even numbers. So that's going to be my conjecture. My conjecture is that the sum of 2 odd numbers always ends up equaling an even number. Now remember, for right now, that doesn't automatically make it true. I'm just saying that's a pattern I noticed. And I'm gonna say for now, I think it might be true. That's really what you're doing when you make a conjecture. You're noticing a pattern, you're saying, hey, maybe this is always true. So that's what we've done so far. We made a conjecture, and our conjecture is every time you add 2 odd numbers, you always get an even number. Okay, I mentioned during Module 12, we're going to talk about how to prove these things are right. Now, it's a lot easier to prove that a conjecture is not true than to prove that it is true. So let's start with that. The reason is, it only takes one example to prove that a conjecture is not true. If you have a conjecture and you test it 1,000,000 times and it works every single time, but then on the 1,000,001st try, it doesn't work, that conjecture didn't work. It was false. So even though it worked 1,000,000 times in a row, if you can find that one case, that one example that shows that it doesn't always work, then the conjecture itself is not true. In order to be true, a conjecture has to always work. Now that one example that shows it doesn't work is called a counterexample. And you can see it right in the name. An example is an example of something that does work. The word counter means against or opposite of, so a counterexample is an example that it doesn't work. So for our last example today, let's start, number one, we're going to decide if this statement is true or false. If we think it's true for now, we'll just say it's true, because we haven't talked about how to prove that yet. But if we think it's false, we're going to give a counterexample. So I read the question, and I said if angle ABC is congruent to angle DBG, then angle ABC and angle DBG are vertical angles. So I say, well, I know vertical angles are congruent, but what I'm asking you right now is, does that work backwards? You know, if you have two vertical angles, they're congruent. But if you have two congruent angles, does that automatically mean they're vertical angles? I think that's false. I think I can come up with a counterexample for that. I think that's false. And my counterexample is not going to be a sentence this time. My counterexample is going to be a picture. So let me do this. I'm going to draw a straight line here, and I'm going to split it up into 3 angles. And I'm going to make the first one ABC. And then I'm going to make the one way over on the right, that'll be angle DBG. And in my picture, I'm going to mark them congruent. Because I'm drawing the picture, I can say whatever I want. Now my picture is now a counterexample. Because in my picture, this part is true. I said angle ABC is congruent to angle DGB. But they're not vertical angles in the picture. So I have created a counterexample. If I can show one example that shows that that sentence is not true, then that means the statement is false, period. And that's how counterexamples work.